Hello, I'm Tony, the Scarred Ghost. Today I want to talk with you about one of my favorite topics. It is camera access on a standalone headset. Meta has just released an experimental SDK to let you grab the camera frames from your Quest 3 or Quest 3S. And that's pretty exciting because it means that from a Unity or a native Android application running on the Quest, you can have access to the camera frame, so see what the user is seeing in front of him or her, so you can analyze the surroundings, maybe thanks to AI, and provide more contextual and more immersive mixed reality. But there is a but. The SDK is experimental, so they just released this first version, which has some little problems that let me had some headaches while starting with it. So I'm making this tutorial so you can avoid my issues and be very fast and very happy to get started with camera access on Unity. In particular, I will show you how to get started with the latest Unity, so Unity 6, because that's the future of Unity, and so I think it's good that you start a new application using the new version of Unity. But whatever I say, more or less, will hold also for previous versions of Unity. You may be wondering, what kind of application are we going to build in this tutorial? And the answer is, I'm the Unity Cube guy. You're going to make a cube in Unity with the pass-through texture all over it. Sounds exciting? To me, yes. That's the beginning of your journey in pass-through AR. So let's get started. Big caveat about this video is that pass-through APIs are experimental, are in beta, and Meta is going to improve them over time, depending on the problems it finds. So, for instance, I'm going to tell you about a bug that there is currently in the samples, but maybe when you download the samples, it's already been fixed. So, whatever I'm saying to you is specific to the current moment I'm making this video. Things may change day by day, so you have to adapt what I'm saying to the situation you find. The general concept I'm coming to you are going to stay the same, but some little steps may be different. So, just take what I say with a grain of salt and happy coding. So let's start with the boring part. This is the prerequisites. So first of all, you can find the documentation about this feature on the Meta Horizon Developer Hub. So here in the documentation of the Unity SDK or the native one, if this is what you want. This tutorial about Unity, so we'll focus a lot about Unity. And the prerequisites are, first of all, you must have a Quest to Quest 3S. So this functionality doesn't work like on Quest 2, at least for now. Maybe they will make a porting later, but for now it's Quest to Quest 3S. And then you must have Horizon OS version 74 or later. So it must be updated. If your Quest, like mine, was still a 72, I triggered an update. You can find online a lot of tutorials on how to update your Quest, because now you can manually update it most of the time. So go to version 74 and get a Quest 3 if you don't have one. Second thing to remember for this tutorial is the version of Unity, because it is suggested by this sample. I will explain in a while what is this sample project, to use one of these two versions of Unity, 2022.3.58 or Unity 6 0.38. This is the recommended one, but actually it should work also with slightly different versions. I did all my work with Unity 6.0.34 and everything works the same. So it's not you have to have the 38, because otherwise, we have our drives full of Unity versions, but try to be on an updated one. I think this is the most important thing. And one important thing to remember is that these APIs are experimental, which means, first of all, that you may have some issues, like I had, and then that you cannot publish whatever you do on the Quest store. You can still use side quests, you can give it an APK online, whatever you want, but for now you cannot publish on the main store. But remember, this happened for many features before this one, and later, after a few months, Meta always allow them to be on the store. So I guess they are finalizing the SDK. They also want to check privacy-wise how these things are working, and then they will allow you to publish whatever you're doing. So it's good to start experimenting now so you can publish your application later when you have polished everything. Okay, so enough with these boring prerequisites. Now it's time to dig into the problem. So how does camera access work? Well, this is the quest tree. You have left and right cameras, so you can have access to one of these two strings. So now the depth camera is not included, but you have already some depth APIs in the SDK, so that should be fine for now. So reading a camera on your phone with Android, because remember the Quest is still an Android device, happens with a class called camera2. You can find it in the Android documentation. This is, if you ever worked with Android and make an application where you get the camera to take a photo, whatever, you always use camera2, or now there is also a newer API called like CameraX. But camera2 is more low level, and you can have access to the data, to the metadata about the camera, get the camera frame, etc., etc. If you are working with Unity anyway, you almost never use camera2 directly because you cannot call easily the native API of Android from Unity. You can use what is called JNI, but this is a bit a nuisance because you have to do a lot of mess to create a wrapper between the two words. So what we usually do is using the WebCamTexture functionality. WebCamTexture is a special type of texture in Unity that you can associate to a webcam, which can be a webcam on PC or your whatever camera on your phone, and the texture gets basically every frame the frame of your camera. So you don't have to update it manually, you associate it with the camera and it gets a camera stream. So you can associate this texture to a material, for instance, and seeing the preview of your camera in your application. So WebCamTexture is old stuff. So it's something is in Unity since ages. You can find a lot of questions on it on Unity forums. You can find tutorials, etc. I don't have to explain to you in this video WebCamTexture. You can really find millions of resources online. And also there is documentation, of course, on the Unity website. And you can see that, of course, to access camera on Android, you have to ask for authorization, and then you have your texture. You may say, yeah, but what if I want to access to the pixels of the webcam? Well, you still use WebCamTexture, and then there are the usual get pixel, get pixels, get pixel 32, whatever, to get the pixels of the texture. By the way, the get pixels is kind of slow. API is also blocking, if I remember well. If you don't want to block the flow, you can use the async reading from GPU, but it adds a bit of delay of latency for your reading. So you choose what poison you want to have while reading data from your texture. But still, it means that if I have a webcam texture, I can do whatever I want. I can do a preview, I can access the low-level data, and I can take then this low-level data and give it to AI, whatever. So the purpose is having a webcam texture associated with the left or right camera of my Quest. So you may ask me, Tony, yeah, but I could do this even before? No, because even if Quest is Android, Mate is a modified version of Android, basically. It's a customized to be accessed more than modified. And Meta customized it to prevent camera access for privacy reasons. So if you try to use camera2 natively or WebCamTexture inside Unity, basically you obtain nothing. So now they basically allowed what should have been allowed since the beginning. And an extra good thing of the approach that Meta is having, well, there are two extra good things. One is that you're using the standard methods of Unity that is used also on the phone. So you can create cross-platform applications between MR and phones, whatever. The second is that Android, if you remember well, I broke the news about Android XR allowing camera access through camera2, camera X, and the usual things. So it means that if you develop an application for Quest using these APIs, maybe with just some slight modification can also work on Android XR. So it's good they chose this route because this guarantees a lot of cross-platformness. So that's great. And now now that you know how things work behind the curtains, it's time for us to access this webcam texture. Okay, so now it's time to get our hands into the code. How to get started with camera access? Well, if you read the documentation here, basically it explains how camera access works, blah, 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 blah. But it also tells you that to get started, you have to start with this open source project that Meta itself has shared. Still, there is the Oculus name. It's always very confusing between Oculus, Facebook, and Meta sometimes. But anyway, apart from this, you have this project. This is a project that you open, you can build, and see some samples where you can have many things, because in the samples there is something about estimation of brightness, which means having basically access to the pixel, just having a preview of the camera, detection of objects using machine learning and Unity scientists, showing a modified version of the camera using some shader, but this is, pretty normal if you have already a texture. And also there are other things, like one that is very interesting is having the possibility of going from the 2D pixel of the image to a 3D coordinate in workspace. So that's pretty cool stuff with a project that is already configured. So this is one method. We'll see the other one when I will get started with the project from scratch later, because I'm personally a big fan and a big hater of having sample template projects. The reason why I'm a big fan is that you can start on something that works. So you can learn the project, you build it, you try the functionality, that's number one. And second, you have a ground truth that builds and works, so that if you can start your project, if something doesn't work, you can use the sample and check what is different between the two. The thing for which I'm not a big fan is that usually they're just given this way and you're like, yeah, but I already have a project, I want to implement this feature, and you have to yourself extrapolate the functionality from it. Luckily for you, I already did this work, so now I show you how to use this sample project, and then I will show you how to get started or integrate a functionality in an existing project or create a new one, basically. So this sample anyway is very cool because it gives you an overview of the main things you may want to get started. There are other samples that are pretty cool, made by my friend Roberto Coviello that works at Meta, and he created additional samples to show you how to pick a color, again, how to use object detection, QR code tracking with zebra crossing, which is a Google library, a lot of stuff. So OpenAI, etc., etc., etc. So this is another link. You will find all the links in the description of the video, of course. But for now, let's go for the official project and how to use it. So first of all, download it, clone it, however you want, using Git, or download the zip. Usually prefer to clone, because if there are some large files, sometimes with zip things get messy. So I'm not here to make a GitHub tutorial, so clone this with your GitHub client in some folder of your hard drive. So here I am, I cloned the project here, and you can see there are a lot of cool stuff inside. So what you have to do now is open it with Unity. Now I already added it here, but basically what I did is add project from disk, and then I select this folder. I guess you know it, but repeat it as you want, as Roman said. So you see that the project is made with Unity 2022, and this tutorial is about Unity 6. Some of the difficulties you'll find are related to the fact that this is not a Unity 6 project. So let me pick a version to open it, and I will use my version of Unity 6, which is not the recommended one. The recommended one is 38, mine is 34. As I said, it still works. And I open it already with Android, so I have to avoid to re-import things 2 times. So let me open it with Unity, and it complains, yeah, change version. Now it will trigger me another thing about the database, continue. And now let's wait 2, 3, 4, 5 hours that Unity does its job. Okay, now that Unity is open, you will find something like this. So there is in the documentation something you can follow, by the way, to use this project. So you say configure the Unity project to use PCA, something like this. And there is one very important thing you have to remember before building, or better, two. The first one is clicking on Meta Tools, Project Setup Tool, and fix this thing. If you don't fix this thing, basically you have the wrong game activity name, etc. The application doesn't start. I'm saying it right. It doesn't work. So if you don't do this fix, nothing works. So you see there was an error. I clicked on fix, over. And this is thing number one. Then thing number two, and this is a suggestion that gave me because I couldn't resolve this out myself, by the great Takashi Yoshinaga, which is an amazing guy that makes fantastic things with HoloLens, with Quest, etc. Mixed reality. Love him. So follow him on social media because he's really great. And basically, he told me that the thing you have to do is go to Meta Tools, update Android manifest. Overwrite or locus specific, blah, 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 continue, overwrite. If you don't do this, basically the application doesn't work. Notice that there are other possible ways to fix this. There is also the great Dilmer Valisios, the guy making probably one of the guys making most tutorials about XR, who gave me another suggestion about things that you can change in the first lines, type of application that is going to be built. You can check his tutorials. That's another way of solving it. But the update, I think it's very easy. And notice that anyway, it will conserve all the required permissions. So the update is good, but there is another thing you have to fix. And this is something that is relevant also for the next tutorial, because the thing about the manifest is specific to this project. The other thing is really an error that at least for Unity 6 is in this plugin. So if you go to the pass-through camera, which by the way, we'll see soon is where the meat of the sample is, so the real facilities, and you go to script and WebCamTextureManager, you open it because we have to change a thing. Basically, long story short, if you don't do this modification, the application is going to work the first time and is going to crash all the others, unless you uninstall and reinstall it again. So what you have to do, and here again, there are two possible ways. And both approaches are about waiting for some frames, because it seems that you can see there is also a comment here about you have to wait to prevent exceptions, because there is some initialization that the system has to do before allowing you to get this webcam text. So Takashi, the guy mentioned before, suggests here to wait for more frames. Here there is a wait for 1 frame, and he suggests to wait for more. He suggests to be totally sure to use 200 here, something like that. It's a lot, but this way you're totally sure. Anyway, 200 frames is not a very long time. I found another way which requires you to write a bit more code, but I think it's I like it a bit more, let's say, because I do it in the beginning, but both solutions are absolutely valid. So the fact is we have to wait a bit here. So let's do like this. So here you can do an else. No, not this one. Pilot is always willing to do too many things. And here we can start coroutine. And it is wait and initialize. No, I don't know why Copilot always corrects things. It shouldn't correct. So, okay, that's much better. So now we have to wait, but it's not necessary to wait a lot. I noticed just return 2 frames here is enough. So yeah, return null, yeah, return null. If you do like this, basically the system, before doing all the initialization of the texture, will wait 2 frames, which is not a lot. And anyway, in this class, you have you provide the texture, but the others have to verify if you already are initialized. So if you wait 2 frames more, everyone will wait 2 frames more, and things work. This approach anyway requires you to write a bit more code. So you decide which one you have to follow. I don't know why it's complaining. Okay, I got why it was complaining. You have to do this so it knows you want to explicitly trash this value. And if you do this, everything should work. So now I'll take this approach of mine. And basically what I'm going to do is get back to the Unity sample. And now building and running, everything should work. So let me try build and run, and connecting, of course, my Quest tree to the PC. Of course, my Quest is in developer mode and blah, 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 blah. Everything should work also because now it's not asking me where to put the build because I already built it a lot of times. So it will be also faster in building for me. For you, it can take something even 15 minutes because it uses IL to CPP. So the build is over. The application now should run on my device. So let me put my Quest on and start the stream. Well, side quest today has decided to be this way, but anyway, let me start passthrough camera. You see there is a menu and I can do, for instance, camera viewer. And now you should see a lot of, you see there is a preview of my camera. I can exit this one, I can do brightness estimation. And if I put this in front of the cameras, they become bright. If I remove it, they're not bright anymore. So the sample is working and I can close it. I can reopen it and it still works. And this is because we modified that script that we saw before. So you see there is now a modification of my camera view with a shader, which is pretty weird, but anyway, that's not the point of this video to talk about the sample. The samples are very good. So the system works and that's great. Now what to do with what I showed you? Well, basically you can go to the various scenes that are here, you know, brightness estimation, camera toward, etc. Analyze how they are done, modify them and create basically your own tests. You can start maybe with the brightness estimation and do your own test that requires the total brightness or contrast, whatever. You can start with this the sample about object detection and do some other things with Unity scientists and apply machine learning algorithms to your camera view, whatever you want. So that's a good starting point. You can also create a new scene in this project and modify it. There is the guide exactly how to do that. So I'm not going to repeat what's already written here. You already have the docs that explain you how to modify these projects and these scenes, but I think it's easy. You see how they're done and you try to mix a bit using your knowledge and obtain your results. I would like to tell you that the main features, as I said, are in passthrough cameras. In the passthrough camera folder, this is where maybe I want to discuss a bit more how this works. But I think it's better to do that starting from a new project. So I show you all the process of using the passthrough camera API without having to start from the sample. But we'll start from scratch so you learn how to use your own project or a new project. But still, even if you do that, I still suggest to download the samples because we will still get this folder from here. And the reason is that basically there are a lot of facilities in this folder that I guess that this folder will be part of the Meta SDK when the feature will not be experimental anymore, because it makes no sense for this not to happen. So either will be part directly of the SDK, or will be like an add-on to the SDK, you download it directly from Unity, because this is the facility to get the camera texture in an easy way. So that's why even if you don't plan to use this sample, even if you don't want to analyze how Meta did things inside the samples, which I still don't recommend, I think it's good to study here in this project, still download it because we'll use it now. So now let me close all of this and let's go into the starting the project from scratch. Now take a deep breath and let's start from scratch with Unity 6. Okay, so let me open Unity Hub and say new project this time. I select this editor version Unity 6, the Unity 6 version I have, the latest I have on my hard drive. I give project name passthrough access test true because I already have the one on my disk. Don't connect to Unity Cloud, I don't need it. And I select Universal 3D Core because anyone works with URP on Quest. So create the project. And now, as usual, let's wait 2-3 hours that Unity configures everything. Let's see later after the coffee. Okay, I lost 2-3 years of life, but finally the project is open. I noticed that the first time the creation Unity 6 is pretty slow, but then the times after you open the project, it gets much better. So let's start doing something with this project. So first thing first, build profiles. Let's go to Android and let's switch platform. Let's do it in the beginning to avoid having to re-import a lot of stuff later. Okay, 2 years after, this is ready too. Now, if you want, you can go to the player settings. You can change the name of the company from default company. Let me put Scarlet Ghost, for instance. And let's check the name of the package. I don't want to override it. I want to be the standard com Scarlet Ghost, blah, blah, blah. So that's the first thing to do. So you can build with the name that you want. But this is just a detail. You can also avoid this step. It's just to have the names that you're expecting. Now let's install the Meta Quest development package, the MRUK, Mixed Reality Utility Kit, and go so to Window, Package Manager, and then let's do the node way. Let's install package by name. And the name is com.meta.xr.mrutilitykit. com.meta.xr.mrutilitykit. And install. If the name is correct, it should start an installation. Okay, the name was correct. There was a moment of pause, a bit too long, so but it's now installing the package. So if Unity at this point prompts you to restart the editor, do it. Okay, so now that the editor is restarted, we can close the package manager. We can also close this introduction to the Meta SDK. Of course, you can read it, it's very important, but not now. Now let's go to file. Now let's go to edit, project settings. Let's go to XR plugin management and install the XR plugin management. This is useful, of course, to let you manage which plugin you want to use to manage XR inside your project. I guess you already used a lot of time. Okay, so now the plugin management is installed. You can modify the one for the editor if you want to make some test with the editor. So let's do OpenXR for PC. It's not strictly necessary for what we are doing now, but usually if you want to do also some tests inside the editor, you need to specify which plugin to use also on the PC version. That's why I'm setting it. Okay, now we have this blah blah. Do you want to enable the XR feature set from Meta? Yes, I want to enable them. So there is this thing, and then we do it also for XR plugin management, Android this time, also OpenXR, because I want to go for OpenXR. Also, Meta now is suggesting to go for directly for the OpenXR plugin provider. So that's the right thing to do. But we have to do a few things. So first of all, both for PC and Android, we need to add interaction profiles. So now you select your controllers. I usually put both MetaQuest Touch Plus and MetaQuest Touch Pro in both PC and Android. So now we are done on this. And now there is the project validation. There are lots of issues. You can check them one by one if you want, but the easy thing for me is just to fix all for the purpose of this tutorial. Okay, if you want, you can also do the same on PC and wait for some things to happen. Okay, now that everything is validated, here let's get back to our project and let's delete everything from the main scene. And let's go to the building blocks, which is a feature I love, and put in the scene these three things. First of all, of course, a camera rig, so we can use the headset. Then pass-through, so we can have the vision of the pass-through, of course, and a controller tracking, so we can see our controllers. Of course, the controllers, if you want to use hand tracking, you can use other stuff, but I mean, that's not the point of today. You can do the application that you want. Now I just want to do cube and the controllers, and that's it. So now you can check there is another check you have to do. After we solved all the problem with OpenXR, we have to go to the Meta XR tools and check the project setup tool. So this you can do apply all again, but don't do the last one. So this one, the one about the scene in your project, do ignore. The reason is that the prefab we're going to add is going to ask this permission itself, and you don't want to ask permissions in different places of the application. So ignore this because we are going to ask some permission in another way. For the other two, you can do apply all. And now things are great. So even Meta here is happy. And you have your sample set. So if you build now, you just see your pass-through, and which is great, but let's say it's just part of the things you want to do. So now you have to get back to the project we downloaded before of the samples. So I told you that even if you want to start a project by yourself, you still have to download the samples. And the reason is, as I said, there are facilities in that project that if you want to recreate, you spend a lot of time, and it's useless because Meta already did it for you. So you have to go to the project you downloaded, assets, then if I remember well, is pass-through camera API samples. Then you take the folder called pass-through camera and you just drag and drop into the assets folder of your project. You just need pass-through camera. The other things are facility related to some samples. The pass-through camera is the one gives you the facilities to get the webcam text, which is our purpose. So we just grab that. And we have now this folder, and you see there is a prefab called WebCamTextureManager prefab. Drag and drop into the scene. This prefab, as you can see in the documentation of the sample, has a script that lets you choose which camera texture you want and with what resolution. If you put 00, it gives you the maximum resolution possible. It works on asking camera permission, and you see it asks the camera permission about using the scene. You need the scene because so you can make some heat tests also with the between the camera rays on the camera frames and the world, etc., etc. And that's why before we said we don't want to ask the OVR manager to ask for the same permission, because this script is going to ask the same permission. So this is just a permission request for Android. What do the other scripts do? Long story short, they let you obtain the webcam texture from Android, and not only the webcam texture, but also the data about the camera. So the camera metadata, the camera intrinsics that are very important if you want to do 2D to 3D mappings, etc. So there is initialization, there are utilities. You could do this also by yourself, but why if it is already available? Notice that currently there is a limitation in the script made by Meta that only lets you have one eye. I have to investigate if using the native plugin I can get both eyes. I guess it's possible, so that could be cool. But for now, let's stick with what is available. You see there is still the fix I applied before. Notice that if you download, I suggest you download the samples, because while we're speaking anyway, the samples are being updated to fix errors. So maybe you don't need my fix. If you need it, apply it. If you don't need it because the sample has been fixed, just import this file and that's fine. Another thing that I wanted to show you is the passthrough camera with this, because this one shows you calls to the camera 2 functions. It's like at a certain point, let me check. This one, you see these are J and I calls. You create an Android Java class and you call methods. You see it's pretty clunky. Maybe this is just a call to a function that in Java is one line and here is like 4. So, and here it's getting the data about the cameras, it's initializing what are the cameras, it's finding them, blah, 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 blah. So already done, that's great. So how do you use this? There is only one thing that I'm a bit puzzled about this sample. So here it creates a WebCamTextureManager. I don't know why this is not like a singleton or whatever, because it's made to be the provider. So it should be a singleton or something like that. But anyway, in this moment it's not a singleton. So you have to find it in the scene or assign it as a reference. Basically, this WebCamTextureManager has an exposed field, which is WebCamTexture, which is the WebCamTexture that you want. So you don't have to do anything. You have just to find this guy and ask him the WebCamTexture. Done. So easy peasy. So what do we do? Well, very, very simple. We have to do one thing. Let's put a cube. I promised you a cube. So 3D object. I click the right button of the mouse, or we can do here if you want 3D object cube. Cube, fantastic. Let's put just that 2 coordinates in front of you so it's more visible. You don't have to move much to see it. And now we want to put a texture on it. So let's create a script. Let's do the plus here, mono behavior. No, sorry. Let's create a folder before, because I want to be a good guy and call it scripts. And then inside this mono behavior script, and let's call it webcam texture assignment. So what code are we going to put here? Basically, we're going to put the code to take the webcam texture from that script here and assign it to the cube. So we can double click on here and modify the scripts in this way that I'm showing you. So to make things faster, I just wrote a script. I will put this in a Pastebin that you can find in the comments, or you can just stop the video here and copy the code. So I'm just requiring there is a renderer on the object using the script. And basically it will loop until, first of all, it should find the WebTextureManager using the find first object by type. By the way, newer version of Unity, maybe if you're used to older version, there is a find object of type. Now it's deprecated. You should use find first object by type. So I loop until it's found, but it should happen in the first frame. But anyway, just to be sure. And then when it's found, so it's different from null, I can get webcam texture this way. Of course, this is not an optimized script, blah, blah, blah. It's for a sample to make you understand. When I found this, I get a texture and I keep looping, waiting for a frame until this texture is not null. Notice that the more you add weights to the WebCamTextureManager, as we saw in the fix, the more this will return null after more frames. Notice that, by the way, the start is an enumerator, is a coroutine. I don't know if you know this trick, but it's very useful in these cases. When the webcam texture is finally not null, you can assign it to the component of the renderer of this current object, and as the main texture of the main material of the main renderer of the current object. Long story short, you attach it, the script to the cube, it gets magically the webcam texture of the camera from the manager and assign this texture to the material of the cube. So now the thing that we have to do is to take, I saved it, yes. I take this script and assign it to the cube. Now that we did it, there is still one last thing we have to do before building the application, which is going to plugins, Android. There is a manifest, and basically we have to make this manifest acquire all the permissions. So let's go to Meta Tools, create store compatible manifest, replace, that's fine. You see it has added a lot of things about passthrough and all the rest. Before they were not there, you see. But we need to add another line, which is uses permission. So copy this one of use scene. And the uses permission. Android name is Horizonos. Horizonos.permission.headset camera. Let me show you. And this should be enough to make the application ask the permission to have the access to the camera. So save this file. You can close Visual Studio now and save the scene as well, save everything, and now we should build, and if everything works, the cube as webcam texture. The moment I proved you can get the webcam texture in with this script that I just created, is the moment that you can do whatever you want in your project, because as I showed you in the beginning, the moment you have the webcam texture, you have the image from the camera. So let's build it. So build profiles. If you use like me the sample scene, it's already here in the build profile. You can only connect the Quest to your PC and hit build and run and do whatever you want. I usually create a folder called builds and I call it passthrough sample 2. Save. Here it may complain about this input handling, blah 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 blah. Yes, for now, yes, this is something you may fix later for other projects, etc. Usually I used both in some projects in the past and it worked. To be very honest, when you want to do a clean project, you usually should use the new input management system. For now, for the sake of this sample, let's hit yes and who cares. And now we have to build, and building takes a lot of time. It's CPP is going to take at least 10 minutes. So coffee again or whatever you want, and then see you later. Okay, after 1 million hours, you see the build is completed. So it's time for me to put again my headset on and hopefully let you see what I'm seeing. So start stream. Okay, I don't know if you see it. Yeah, you see it. Let me zoom it. Apart from the mess on my desk when I'm experimenting, yeah, it always becomes like that. So it asks me the permission. So pictures and record video for the pass-through. Headset cameras, of course, is a permission because you want the user to approve that you are accessing the cameras, and special data for the scene. So allow. In this moment, there is a bug. If you don't allow all of three, only you do one and then not the others, you have to uninstall the rest of the application. So allow all of three of them. And you see, it worked. There is a cube with the pass-through vision. You see, now I'm putting the keyboard, and you should see the keyboard on the cube like that. So the access to the camera worked, we have the webcam texture, and that's amazing. So, but you may have just a final question, like why it's so dim in colors, why it looks almost black. Well, the fact is, to make a quick test, of course, I didn't make you do things in a perfect way. Let me close the build here. So the cube is basically using the standard lit material, and there are no lights here. Also, when you do these kind of things, usually you want to put also an unlit material, so to see the image in a bright way. So, but this is just a detail, and it depends on the implementation that you want to do to your project. So what we wanted to prove is to have a cube with a webcam texture, and it worked. So we have it. So this ends my tutorial because I reached my goal to show you how to get the texture and put it on a fantastic cube in Pastebin Mixed Reality. Now what you have to do is to start from here and do whatever you want with starting from the samples or starting from scratch, and experiment with pass-through vision and see what you can do in analyzing the environment in front of the user. So I hope you like this tutorial. Before ending, I want to thank people that helped me in arriving here and learning how to make stuff. So Takashi Yoshinaga, Roberto Coviello, Dilmer Valicios, a special mention for these three guys because they gave me some suggestion on Twitter while I was a bit scrambling and getting crazy on how to do stuff. So as you can see, the power of the community is making the technology go further because we are pushing it all together. And I also want to thank you for watching this long video, and I hope you will have fun with passthrough XR. Please, if you like this video, subscribe to my channel, like the video, share it with your dev peers, and also read my blog and share it around. So thanks for all your support, and I wish you a great day in VR with passthrough vision. Bye bye.